Today we are going to learn about Linux file and directory permission. In a Linux system, a user logs in using their username and password. That is the basic identity verification process in Linux. The users can create files and directories. In multi-user system like Linux, managing file and directory permission system is therefore very important. In this class, I am going to teach you the importance of the file permission, then different levels of file permission system, how to change file permission, and how to change file ownership. In Linux, files and directories are considered in the same way, since directories are some special kind of files. Now let's go to explain file and directory permission. We know that Linux is a multi-user operating system. So collaboration with the other users is a major benefit, but at the same time we need security for the files and directories. That is why Linux implements a permission system that addresses two concerns, namely, number one, who owns a file or directory, number two, who can access or perform certain operations on those files and directories. In order to manage the permission system, we also need to modify those permissions that adds a flexibility to the system. Now, as we are talking about the files, the file and directory permission can be easily seen if we list the content of the file system. So we can execute ls-l comment and the resulting output will be similar to the screenshot in the left. If we analyze each record in the output, we can see there are 7 columns. Column 1 shows file type and permission. If we further split that field, you can see that the first character represents if it is file or directory, etc. The next 3 characters represents the permission for the user. The next 3 characters represent the permission for the group, and the final 3 characters represent the permission for the other. The column 2 represents the number of hard links pointing to the files. The third column is the user or the owner. The fourth column is the group owner. The fifth column is the file size in bytes. The sixth column is the timestamp, and the seventh column is the file name. The first column is the most relevant field for analyzing the file permission. Now there are 3 levels of permission: read, write, and execute. And these are represented by R, W, and X. Now this table summarizes their interpretation for files and directories. For example, read permission is the permission to open and read a file. For directories, it is the permission to read the directory's contents. Similarly, write permission is a permission to modify a file, and for directories it is the permission to add or remove files under the directory or to rename. And then execute permission represents whether a file can be executed. For directories, it is just a permission to enter the directory. We have not discussed yet about the fourth column. The fourth column represents the numeric representation of read, write and execute. For read, Linux assigns a value of 4, for write it is 2 and for execute it is 1, which means if a user has read, write and execute permissions for a file, then the numeric representation of those permission is 4 plus 2 plus 1 is equal to 7. I also want to mention that these permissions are not additive. That means users, group and others, each mode needs to acquire those permissions separately. Now let's see some examples. I have listed here 3 files with different permissions. The first one, that is the test file, has its user, group and others all have read, write and execute permission. The second one, test file 1, shows that user has read and write permission but group and other has only read permission. The last one, test file 2, shows that the user has read and write permission, group has read permission while the other has only execute permission. So permissions are clearly readable from the list of output. Now we want to learn how to modify file permission. We use chmod command for that, which has 2 arguments. The first argument is permission to change and the second argument is the file or directory where the change will be made. We can change the permission using symbolic and numeric mode. For numeric, we can see a set of numbers, but for symbolic mode, we can see some characters. For the same set of permission, both modes, numeric and symbolic, give you the same result. Now let's focus on symbolic mode to change file permission. Now here 2 points to consider. Number 1, whose permissions we are changing. There are 4 possible ways: user, group, other and all. And number 2, what are the changes we are going to do. There can be 3 different changes. Number 1, granting a permission which is represented by plus symbol. Number 2, revoking a permission and this is represented by minus symbol. And number 3, setting is represented by assignment symbol. Now here are some examples. The first example is adding a write permission to group. We use G plus W symbol as an argument. If we revoke read permission from user, we use U minus R. Then if we assign read, write and no execute permission to all, then we assign A is equal to RW. We can also change multiple permissions at the same time by combining them with comma symbol. Now let us consider numeric mode. We already mentioned that the permissions are represented by 3 digits numeric value. For read it is 4, for write it is 2, and for execute it is 1, and for no permission it is 0. One example is there. You can see for user it has read and write permission. For group it has read and write permission, and for others it has no permission. So which syntax we should be using, numeric or symbolic? Now the general rule of thumb is we should use numeric if we change the permission to a specific value, and we should use symbolic if we want to flip just a single value. Now you can change file ownership using chown comment. First of all, you need to find the group for a user using groups comment. In this case, user Mint is a part of two groups, Mint and test2. The next screenshot you can see that the file test1, it is associated with group Mint. Now we want to change the group of file to test2. If we use this chown comment, then you can see that the group is changed to test2. Similar results can be obtained using chgrp comment. One thing you should note here that only a super user can change user and or group ownership. Now there are 3 different special permissions we are talking about. These are sticky bit, set user ID, that is SUID, and set group ID, that is SGID. Let's talk about sticky bit first. This is also called restricted deletion flag. It is denoted by octal value of 1, and it is represented by symbolic value T within other permission. Now if we assign sticky bit on a file, then it prevents the users from removing or renaming a file in a directory unless they own the file or directory. I have also added a screenshot where I assign sticky bit to a directory. Now the second special permission we are going to talk about is set user ID. It is associated with octal value of 4 and represented by S on the user execution permission in symbolic mode. Now if the SUID is set on a file and that file is executed, then the person who executed the file temporarily becomes the owner of the file while it is executing. Example is password comment. In this screenshot, I am showing how to set user ID on a file. Now the third special permission is setting group ID. Its octal value is 2 and is represented by S on group's permission. Now on executable file like a shell script, it will grant the process resulting from executing the file access to the privileges of the group who owns the file. Now I have also included a screenshot showing how set group ID on a file. You can combine multiple special permissions by adding them together. Now in this example, we combined group ID and user ID together. That means we added 4 plus 2 and made the permission like 6777 that sets user ID and group ID simultaneously on that file. Now we can summarize what we've explained so far. Now we have explored file and directory permission in Linux. Then we discussed about how to change file and directory permissions using symbolic and numeric mode. Now we also discussed about changing user and group ownership of a file or directory. Now finally we touched base on special permission and their significance. Thank you.